Good morning, everybody. My name is Vinayak Nannoji, Jain College of Engineering, Belgaum. So today we shall see what do you mean by comparators, and we shall study one type of comparator in mechanical comparators. All right. So before starting, we should know what exactly is a comparator. So a comparator is nothing but a precision type of instrument which enables a comparison between the part being measured and a length standard. So it works on the principle of relative measurement system, that is, it gives only difference with respect to basic dimension of the component. It means that it is not going to tell you the dimension like it is 25 mm or 25.1, but it is going to only tell the difference between the basic dimension, that is how far it is from the basic dimension or how close it is to the basic dimensions. So all the comparators basically consist of three main components. The first one is the sensing device, which usually senses the input signal, and then comes the second one, that is magnifying system, which is used to increase the input signal into suitable magnitude, and then comes the display system. Okay, so these display system may be generally like scale and a pointer, or it may be any digital output, right? So this is what do you mean by comparator and the different parts. So now we shall see what are the different types of mechanical comparators and what is the difference. So in mechanical comparators, so in these comparators, magnification is obtained with the help of mechanical arrangements such as rack and pinion, cams, gear trains, right, and other things. So here we are using most of the time rack and pinion and cams and gear trains, which is used to magnify the input signal. So to perform any operation, there is no requirement of any source, that is the external source or the external power, since it is self-controlled comparator. So all the linkages and mechanisms, whatever we have, so it does not require any external source. So the usual magnification obtained by these comparators will range from 250 to 1000. So there are different types of mechanical comparators. The first one is the dial indicator or the dial gauge, what we call it as. Then Reed type mechanical comparators, Johnson's macrocator, and Sigma comparator. So today we shall see what do you mean by dial indicator. Right. So here you can see there are two diagrams, that is 4.2, that is rack and pinion arrangement, and then the dial indicator. So here you can see that in 4.3 diagram, so it is a dial indicator which consists of a plunger, and then you have a contact point. Okay, the plunger is going to move to and fro, and then we have a rotating panel to adjust the zero, and then we have a pointer, a big pointer and a small pointer. So big pointer reads from 0, 10, 20, 30, 40 and so on, and the inner pointer will read. So when the big pointer completes one complete rotation, it means that it has covered 1 mm. So that 1 mm will be shown by the small pointer inside, right? So usually it will be from 0 to 9 mm in the usual dial indicators. So we shall see how exactly it works. So here you can see the plunger. When the plunger moves from its position when it is into a contact surface, so here in 4.2 you can see that there is a measuring spindle which is connected to the plunger, right? So the plunger is connected to the measuring system, and the measuring system is nothing but a rack, and then it is connected to a pinion. So what exactly we are doing is that we are converting the linear motion of the plunger into rotary motion. So whenever the plunger moves, it is going to make the pinion to rotate, and in turn it will rotate the remaining gear trains. So these gear trains are used for magnification purpose, right? So we have set of gears which are meshed with each other, and then at the last we have the scale and the pointer. So the gear train design depends upon what magnification is required, right? So if the magnification required is more, and then the gear train also, or the design of the gear train also will change. So it all depends upon the magnification level. So as seen in the previous slide, that is the magnification will be from 250 to 1000. So it all depends upon how much magnification we require, and depending on that we design the gears, right? So once again, when the measuring spindle or the plunger moves, the rack moves true and fro, that is up and down. When the rack is moving up and down, which is in contact with the pinion starts rotating, which in turn will make the other gears to rotate with respect to it. By this we do the magnification, and then lastly the pointer or the scale moves. Okay, the pointer moves on the scale and we get the correct reading. So these types of comparators usually tell us the difference in the readings. Okay, so now if I have to measure at 25 mm, so it will tell us whether it is more than 25 mm or less than 25 mm. So usually these are used for mass production, wherein we do not have much time to check each and every component, the exact dimension. So we just want to know whether it has been accepted or rejected. So there we use these types of comparators, wherein it will tell us whether it is within the limit or no. If it is not within the limit, then the component will be rejected, and if it is within the limit, then it will be accepted. Thank you.